Welcome to the Explainer. Today we're going to zoom right into the very heart of matter itself. We're talking about the fundamental particles that make up, well, pretty much everything you see, everything you touch, everything you are. We're talking about baryons.
But before we even get into what they are, let's talk about where they are. And, right out of the gate, we hit a pretty big surprise. You'd think, right, that most of the normal stuff in the universe, the baryonic matter, would be in all those shiny stars and galaxies we see. Nope, not even close. That's only about 10%. The vast majority, the real bulk of it, is just out there, floating in the massive dark emptiness between galaxies.
All right, so here's the game plan for this explainer. We're going to start with the stuff we can see, then we'll define our main character, the baryon. After that, we'll look at how it's actually built, dive into a cosmic mystery that, no joke, involves all of existence, and then we'll wrap things up right at the cutting edge of modern physics.
Okay, let's dive right in. Section 1, the stuff of everything.
This is a really simple idea, but it's also kind of mind-blowing when you stop and think about it. The chair you're sitting in right now, the air you're breathing, it's all made of atoms. And those atoms, well, they're the most common form of what physicists call baryonic matter. It is, quite literally, the substance of our reality.
So you can think of it like this. There's this huge cosmic divide. On one side, you've got baryonic matter. That's all the stuff we can see and touch, the visible universe. But on the other side, that's where things get weird. You've got the non-baryonic universe. This is home to mysterious things like dark matter. This stuff has mass, it has gravity, but it's completely invisible. It's like the invisible scaffolding that holds the entire cosmos together.
All right, so that brings us to the big question. We know it makes up everything, but what exactly is a baryon?
Okay, here's the key takeaway. A baryon isn't actually a fundamental particle. It's what we call a composite particle, which is just a fancy way of saying it's made of even smaller things. And in this case, those smaller things are called quarks, and usually they come bundled in little packages of 3.
And you know what? You already know the two most famous baryons in the whole universe. I'm talking about the proton and the neutron. These two guys team up to form the dense, heavy core, the nucleus, of every single atom out there. And where'd they get the name? Well, it's actually pretty simple. Physicists called them baryons, from the Greek word for heavy, baris. Why? Well, just because at the time they were discovered, they were heavier than the other particles they knew about, like the electron. Kind of love that. A simple name for a particle that turned out to be so important.
So this leads to the next big question, right? If baryons are made of quarks, how does that even work? What's the recipe for building matter?
First up, you need your main ingredient, the quark. The best way to think about quarks is like they're the ultimate Lego bricks of the universe. They're truly elementary. As far as we know, you just can't break them down any further. And just like Legos come in different shapes and colors, quarks come in different types, or flavors, each with its own special properties.
Now, to build almost everything in our everyday world, protons, neutrons, the works, you really only need 2 flavors, the up quark and the down quark. And check this out. Look at their electric charges. They're not whole numbers, they're fractions. That's just plain weird. But it's absolutely crucial to how this whole recipe works.
Okay, you ready? Let's build a proton. You take 2 up quarks and 1 down quark. Now let's do the math on the charge. You've got plus 2/3, plus another 2/3, minus 1/3, and what do you get? A perfect +1. Boom! Just like that, you've created a stable, positively charged proton, the very heart of an atom.
Okay, now that we know what a baryon is and how it's put together, we are ready to tackle one of the biggest, most mind-bending puzzles in all of science. And the puzzle is this: why does anything exist at all? Seriously, it sounds like a philosophical question, but it's pure physics. See, our best theories tell us that the Big Bang should have created equal amounts of matter and its mirror image twin, antimatter. And if that had happened, they would have instantly canceled each other out, annihilating each other in a flash of light, leaving behind a universe filled with nothing but energy. So, why are we here? Why is there stuff?
To get this, we have to meet the baryons, let's call it an evil twin, the antibaryon. For every baryon, there's an antimatter partner. It's made of antiquarks, which have the exact opposite charge. So an antiproton? It's made of 2 up antiquarks and 1 down antiquark, giving it a total charge of -1.
The very fact that you and I are here to talk about this proves that something tipped the cosmic scales. For some reason we still don't understand, in the very early universe, for every billion pairs of matter and antimatter particles that destroyed each other, just one extra particle of matter was left over. Just 1 in a billion. That tiny, tiny surplus is what survived to form all the galaxies, all the stars, all the planets, everything. This mysterious process is called baryogenesis, and you better believe that figuring it out is one of the holy grails of physics today. But hey, the story doesn't just stop with our nice, neat 3-quark particles. It turns out the rules of reality, well, they're a little more flexible than we thought. And that's where things get really, really weird.
For decades, the rules seemed unbreakable, written in stone. Baryons are made of 3 quarks. Period. End of story. But, physics just loves to break the rules. So scientists started asking this completely wild question. What if you could build a baryon out of 5 quarks?
And that question led to the discovery of a whole new class of matter, the pentaquark. I mean, look at this thing. It's an exotic baryon, sure, but its recipe is 4 quarks and 1 antiquark. An antiquark! That was a complete bombshell. A fundamental rule of particle physics just broken.
And let me tell you, the hunt for this particle was a total scientific roller coaster. For years, most physicists were super skeptical. By 2008, it really looked like it just didn't exist, case closed. But then, in 2015, at the Large Hadron Collider at CERN, they slammed particles together with incredible energy and saw it. Clear as day, undeniable proof, the pentaquark was real.
And this incredible discovery leaves us with one final and pretty mind-bending question. If the rules can be bent to allow for 5 quark particles, what else is nature hiding from us? Could there be baryons made of 7 quarks or 9? It's just a powerful reminder that even when we're talking about the absolute basic building blocks of our reality, there's still so many profound mysteries left for us to solve.